Let's determine the drag coefficient of a 75 kilogram skydiver falling through air. This is their projected area, and this is their terminal velocity. There's their mass. So we are told that they're moving at terminal velocity. Here's my force diagram. Forces have to balance because terminal velocity is when the drag force equals the weight of the object. That is an important starting point. I've written down the drag equation so that we can fill in all the known values and solve for the coefficient of drag on the skydiver. Drag force, that's equal to the skydiver's weight weight is equal to mass times gravitational field strength. I'm solving for coefficient of drag. As a matter of a more elegant solution, I'm going to solve this equation symbolically before I substitute numbers. Solving for coefficient of drag. All right, the coefficient of drag then is now a matter of substituting in numbers and solving. Oh, I keep writing that A lowercase. Here we go. The solution to this problem is just a matter now of typing everything in the calculator and getting a numerical result. I get 1.01. By how much would the skydiver need to reduce their projected area so as to double their terminal velocity? How would they accomplish this? How much do they need to reduce A so that the terminal velocity this is written in a weird way, just shorthand so I can understand the problem. How much should they reduce their area so that their new terminal velocity is equal to double their original terminal velocity? I think what I want to do is I want to go back to the drag equation and realize that drag is proportional to a bunch of other stuff times area and velocity squared. So let's see here. At terminal velocity, drag is equal to the weight of the object, so drag is also a constant. So I can do this. A is proportional to 1 over the square of the velocity. I want to double the velocity. 2 squared is what we're looking at. what I did here was I just took the velocity. I don't want to work with a specific number, so I just took the terminal velocity as just a constant. I don't really care what it is. So 2 is the factor by which I want to change the velocity, 1/4. The skydiver should change their projected area to a factor of 1/4 to go twice as fast. They have to significantly reduce their projected area in order to go twice as fast. How would they do that? Well, I'm thinking about a skydiver falling before they open their parachute. They might be oriented horizontally, and so then their projected area is their entire front surface area of their body. To reduce that surface area by 1/4, I mean, maybe I could curl up into a fetal position, maybe I could orient myself upright. The key here is to significantly reduce your projected area. Probably changing orientation might be the way I might recommend that. Thanks for watching.